All right, pre-cal students, this is part 3 of the review for our test on sequences and series. This last part deals with the binomial series. And the first thing you're going to want to do is build this triangle, right? Pascal's triangle, which is easy to build. One's on the outside. And then, of course, you know, every number is generated by adding the diagonal numbers ahead of there. 1 and 1 is 2. This 10 comes from the 4 and the 6. This 5 comes from the 4 and the 1, etc. So it's easy to build. And you just go out to the 6th row or maybe the 7th. So it's the second number in the pattern that actually matches with the exponent. So for this one, that 6 there tells us we're going to use this row right here. So the first thing you're going to do is write down the numbers in that row, but leave plenty of room here. So you want to write down 1, 6, 15, 20, 15, 6, and 1. So 1, write down that, 6, 15, 20, 15 again, 6, and 1. Write down those numbers and leave a lot of room behind there. So then what you're going to do is take the highest power, take the first term, I should say, inside the binomial, and raise that to the highest power. So this x is going to get raised to the 6th power. And then you're going to reduce it by 1 each time. X to the 6th, x to the 5th, x to the 4th, x to the 3rd, x to the 2, x to the 1, and then you leave it off altogether. Here, x to the 9, which is 1. And then you work backwards with that -2. You start back here with -2 to the highest power. The highest power is going to match the power of the binomial. So you start with -2 to the 6th, -2 to the 5th, -2 to the 4th, -2 to the 3rd, -2 squared, -2 to the 1, and then it's gone all together here. So that's the setup. Now that's half credit if you're taking the test, right? But then you got to simplify things. Not much to do here. Let's start just playing on x6. Here you'll need to multiply the 6 times the -2 and get -12. Don't forget your x5. Do the exponentiation first here. -2 squared is 4. Times 15 gives you the 60. Don't forget the x4. Here, -2 to the 3rd is -8 times 20 gives you -160. Carry down the x3. And just do that for the rest of these. -2 to the 4 is 16 times 15 is 240. Carry down your x squared. -2 to the 5th is 32, -32. Times 6 is -192. Carry down your x right there. And then -2 to the 6 is 64. So notice you get an alternating series. That'll happen whenever there's a minus sign there as opposed to a plus. All right, let's do another one very similar to that. So again, this time the highest power is 4. So here's what you want to look at the second number. The first numbers are all 1. That doesn't really tell you much. It's that second number. So for the problem we just did, it was that number that matched the exponent, right? So the problem we're going to do right now, this number here. So that tells us we're going to use this row of numbers. All right, so to be consistent, let's go back. So the first problem we used that row of numbers. All right, so back on number 2. So we're going to use this row of numbers, 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Again, make sure you leave plenty of room behind those numbers. So then you're going to look at the first number in the binomial, and you're going to write that down to the highest power. So x to the 4th, and then reduce it. X to the 3rd, x squared, x to the 1, x to the not at all. Now 2y, we got to treat that as one thing. We're going to put parentheses around that. We're going to start at the right side here. 2y to the highest power, 2y to the 3rd, 2y squared, 2y to the 1st, 2y is gone. Now you got to be real careful about simplifying this. That one's easy. But here you're going to do 2 times 4, which is 8. You have an x3 and you have a y1. Do the exponentiation here first. 2 squared is 4. 4 times 6 is 24. And then we have an x squared and a y squared. Over here we have 2 to the 3rd, which is 8. 8 times 4 is 32. We have an x1, y3. And then here 2 to the 4 is 16, and y to the 4 is what I left off, which is y to the 4th. I should put that on my answer key as well on Canvas. All right, that should be y to the 4th. All right, and that's all there is to that. For the next one here, we're going to use a 5th power expansion. Let me get a different highlighter color out here if I can. Here's the blue one. So we got a power of 5 here. So here's a 5 for the second number. We're going to use this line of exponents. So we're going to write down that line of coefficients. 1, 5, 10, 10, 5, 1. Again, gives you an easy way of multiplying all this out. All right, again, leaving plenty of room. So now you're going to start with 4x. You're going to treat that as one thing. So you're going to keep that in parentheses. 4x in parentheses to the 5th power. 4x to the 4th power. 4x to the 3rd. 4x squared. 4x to the 1. And then it disappears on the last term. And then going backwards with -1, you want that to be in parentheses as well. -1 to the 5th, -1 to the 4th, -1 to the 3rd, -1 squared, -1 first, etc. Now here's the trick. If you don't really want to do all the calculations in your head, you can use your calculator. You can just leave off the variables. Like for here, leave off the x, type in 4/5. It'll give you 1024, but then you take care of the x/5 on your own. For this next term, type in everything like you see it, except leave the x off. Leave the x off on your calculator, and that'll give you -1280. You'll need to go back then and put the x to the 4th on there yourself. Same thing here, type in everything except for the x. You must keep the parentheses there, the negative, keep everything the same, but leave the x off, and that'll give you 640. And then you go back and take care of the x3 on your own. Likewise for all these, multiply everything out, leave the x off, you'll get -160. Go back and put the x squared on there. Type in all this stuff here without the x, it'll give you 20. Go back and put your x on there. Of course, this one you shouldn't need a calculator. -1 to an odd power is going to give you a -1. All right, so that's binomial expansion. The other part is finding a particular number in the pattern. So like, let's say they want you to find the 4th number in this here, or the 2nd number here. You're finding a particular term in a pattern. So instead of doing out the whole series, you can use this formula here. Here's the formula that you need to find a particular term. This here gives you Pascal's triangle, gives you a number from Pascal's triangle. And I'll show you where that is on your calculator. So that gives you the number from Pascal's triangle, and then you're just going to raise a to a power and b to a power. So very interesting is that the n is always going to be given to you. You need to know the n and the r in this formula. The n is going to be the power of the binomial. The r is going to be one less than whatever term they want you to find. So r is the exponent of the 2nd number. So let's go back and show you what's happening here. Look at the previous example. On the 3rd term, 1, 2, 3, notice that the r value was 2. On the 4th term, 1, 2, 3, 4, the r value is 3. The r value lags behind because it starts off with a 0. So that's what's meant by this here. R is 1 less than the term. It's the term number -1. So if you're on the 1, 2, 3, 4, 5th term, your r value is going to be 4. It's going to be 1 less than the term. But it's imperative that you know that, because in the formula you need to know both n and r. All right, so anyway, let's work this out here. So we know that 7 is our exponent, that's our n. We know that our r is 4 because we're looking for the 5th term. 1 less than 5 is 4. So now here's the formula. 7 choose 4 is how we say that. 7 choose 4, and then we want the a power. The a is 3k in parentheses to the 7 minus 4. You subtract the two numbers n minus r. And then the second one, the 2, is simply going to be raised to the r power. So a is raised to the n minus r power, b is raised to the r. Now, as far as getting this number here, which again is Pascal's number, you can get that from your calculator. All right, so let's see. We're going to go, need to scoot up a little bit here. So we're going to go to menu. We want to go to probability, which is number 5. And we want to go to combinations, which is number 3. And then what we're looking for is NCR. And then what you do, you you put a 7, 4 into that argument box. 7, 4. And again, what this is giving us is a number from Pascal's triangle without actually having to look at the triangle. So 35 is what that number comes out to be. Now, once you get that number, you still need to multiply it by other numbers. So like here, this 7 minus 4 gives you 3, so you're going to get a 3 to the 3rd in there as well. and 2 to the 4th is going to be a 16. So you have to go back and multiply all these numbers, 35 and then 27, because 3 to the 3rd, of course, is 27. So 35 times 27 times 16 will give you this number here. All right, so let's look at the last one then. Again, it has the n value is 11, right? So remember, this number tells you the n value. And then the 8th term implies that your r is 7. So Pascal's triangle number is going to be gotten from this. We'll get that from our calculator. So we'll get that one, and then we're going to have the first number to the n minus r. 11 minus 7 is going to give us a 4 up here. And then the second part of the binomial is going to be raised to the r power itself. So here's your setup. You'll find this number from your calculator. Let's review how to do that again. You go to Menu. You want to go to Probability, number 5. You want to go to Combinations, number 3. And then you're going to put in the two parameters here, 11 and 7. 11, separate them with a comma. Your comma is down here, by the way. 11, comma, 7. Enter, and that gives you 330 for that number. So this is the number. If you built Pascal's triangle and looked at the 8th term, this would be the number that's there. All right, so anyway, x to the 4th power, because 11 minus 7 is 4, and then we have negative 3 to the 7th power. We'll calculate that in a moment. But we also need to raise a y to the 7th power. So then what you do, you go back and multiply this number together, and you'll get that negative 721,710. And then don't forget to tag on your x4 and your y7 as well. So what you did, you found a particular term without actually having to build the whole series like we did up here. So that's kind of the advantage of this formula. You can find one particular number really easily without building the whole thing. All right, go back and rework all those, and good luck.